N is for nanotechnology, the study of things less than 1/1000th the width of a human hair. These are the building blocks of nature, and they can be rearranged to build some amazing things, like a light bulb that never burns out, or a car that can think, or a cell phone so small an ant could use it, or a shirt that can give you directions, or a tiny computer that can hold every book ever written. Or maybe some things we haven't even thought of yet, all in less than the width of a human hair. N is for nanotechnology, and it's brought to you by HP, a leader in this science of almost limitless possibilities.
Nanotechnology has the potential to change the world in many positive ways. It will improve many of the products that we use every day and make many new products possible. But how is it going to do that? In a nutshell, nanotechnology is the science of very small things, usually smaller than 100 nanometers. But how small is that? 100 nanometers is equivalent to about 1,000 atoms across or less. At this scale, things that we take for granted can behave in very different ways. You can understand the differences if you think about carbon. If you arrange carbon atoms one way, you get diamond. Arrange them another way and you get graphite. Arrange them randomly and you get soot. The nanotech way to arrange carbon atoms is to roll them into nanoscale tubes. When you do that, you get something amazing. Carbon nanotubes are incredibly strong and light. They'll make it possible to create things like space elevators. The elevator will run up and down a nanotube ribbon into space. Another application of nanotechnology can be seen in batteries. By making the granules inside the battery at a nanometer scale, it's possible to recharge the battery faster, and the battery lasts longer. The nanoparticles have a lot more surface area, and the whole battery works better. Some of the more exotic ideas in nanotechnology involve new assembly methods. Scientists are experimenting with new nanomaterials that can grow or assemble themselves. Right now, most things are made by taking a big piece of material and molding it or shaving it down. In the nanotechnology world, you start with atoms and build things up, giving you incredible control. Cells are already able to do this. The goal is to find ways for human beings to do this as well. Nanotechnology is still a very young science, but once it starts advancing, it will affect almost every part of our lives, from medicine to computers to cars. It will be fascinating to watch it unfold. So that's how nanotechnology works. I'm Marshall Brain, and that's how stuff works.
تقنية النانو أو النانوتكنولوجي، الكلمة اللي نسمعها كثير هاليومين. وش فكرة هذه التقنية وإيش تطبيقاتها في حياتنا؟ النانو باختصار هو جزء من البليون من المتر، وعشان تتضح الصورة سمك شعرة الإنسان حوالي 80,000 نانو، يعني النانو هو جزء صغير جدا من المادة. وتقنية النانو هي العلم اللي يهتم بدراسة خواص المواد والتعامل معها بهذا المقياس الصغير، واللي يخلينا نقدر نطور خصائصها ونستحدث وظائف جديدة لها ونصنع منها أشياء مفيدة. كيف؟ خواص المادة اللي زي التوصيلية الحرارية أو التوصيلية الكهربائية أو الخصائص الميكانيكية زي الصلابة، نقطة الانصهار وغيرها من الخصائص تعتمد بشكل أساسي على حجم المادة بحسب القوانين الفيزيائية المعروفة. لكن تقنية النانو باختصار خلتنا نقدر نتحكم في هذه الخصائص لأي حجم من المادة دون التقيد بالقوانين التقليدية، وذلك عن طريق التعامل مع هذه المادة على هيئة دقائق صغيرة مكونة من بضع ذرات أو جزيئات بدلا من كتل كبيرة، حيث أن المادة في هذا الحجم تعطينا خصائص مختلفة تماما عن الحجم الكبير منها. طيب كيف ممكن تغير هالتقنية الأشياء من حولنا؟ تطبيقات تقنية النانو غير محدودة، فمثلا التعامل مع المواد بمقياس النانو سيتيح لنا مستقبلا تصنيع روبوتات صغيرة الحجم جدا تقدر تدخل جسم الإنسان وتحارب الخلايا السرطانية، وبنقدر نحسن كفاءة الأدوية ونرفع دقة تشخيص الأمراض. في الصناعة راح نقدر نغير خصائص المواد عشان تصير أحسن. مثلا تخيل لو أن قماش الشماغ اللي نلبسه يصير ضد الموية وضد النار، بدون ما يفقد أناقته ولونه. بنقدر نحلل الموية بتكلفة أقل من عشر التكلفة الحالية. بنقدر نصنع قزاز للنوافذ عازل للحرارة ولا يلصق الغبار فيه. بنقدر نصنع حواسيب أسرع بمئات المرات وبتكلفة وحجم أقل بكثير من حواسيبنا الحالية. إنتاج الطاقة، الإلكترونيات، الطب، العمارة، الزراعة، الغذاء وغيرها من المجالات كلها راح تشهد نقلة نوعية باستخدام تقنية النانو اللي ما زال المستقبل يحمل الكثير من آفاقها.
Hey, do you know what nano means? It means small, very small. It is 1,000,000 times smaller than the smallest measure on a ruler. If you want to get an idea of how small a nanometer really is, you'll need to take a piece of hair from your head. Go on, it won't hurt. Got it. Now take a good close look at that strand of hair. Not much to look at, is it? If we were to shrink you down, smaller than the smallest thing you can see with the naked eye, you will find that your piece of hair starts to look a lot more interesting. You are now about the size of a red blood cell. Your strand of hair is a massive tree compared to you. Even at this size, you're still about 1,000 times too big to be considered nano. To get you down to the nanoscale, we will have to shrink you to about 100 nanometers tall. Hey, where are all the lights? You are now smaller than the wavelength of visible light. You are practically invisible. But for the sake of demonstration, I think we should turn on some lights. At this size, the red blood cell is 1,000 times bigger than you are. It is like an enormous stadium. Welcome to the nanoscale. You could probably hold a common cold virus in your hands quite comfortably now. The rhinovirus is only about 30 nanometers across and is nearly impossible to see next to the red blood cell. A red blood cell is too big to be considered nano. However, it's made up of all kinds of nanomaterials. If you were to look close enough, you would see that the outer walls of the cell are stabilized by a flexible, mesh-like protein skeleton. The bars and connectors that make up this mesh are considered part of a nanomaterial. Without these reinforcing nanostructures, the cell would be much more fragile and not nearly as flexible. It wouldn't stand a chance in your body. Everything is made up of nanomaterials. Nanomaterials are an arrangement of molecules and atoms that, when combined, create stable building blocks that can be made into larger, more complex materials and structures. Which is pretty much everything, including this little piece of hair. I bet you didn't think there was so much going on in such a small amount of space.
The space elevator, in simplest terms, is a ribbon. One end attached to Earth. The other end is attached to a counterweight in outer space. The rotation of the Earth throws the counterweight on the ribbon outward, keeping the ribbon taut. Made from an advanced carbon nanotube composite material 30 times stronger than steel, the ribbon is 3 feet wide, thinner than a sheet of paper, and 62,000 miles long. Vehicles weighing up to 20 tons then climb the ribbon from Earth to outer space. Simple electric motors pull the climbers upward with drive treads stripping the ribbon. Power is supplied from a ground station in the form of a laser beam, which is converted to electricity by the climber's photovoltaic array. Located in the eastern Pacific Ocean, the anchor station is similar to a floating oil drilling platform. Additional platforms house the laser power beaming stations, allowing for power to drive several climbers up the ribbon at once. By using the outer end of the ribbon as a slingshot, it will be possible to throw large payloads to destinations such as the Moon, Mars, Venus, and beyond. With cheap and frequent access to space a reality, mankind will be free to pursue our destiny by climbing a ribbon to the stars.